Hello, folks. Thanks for joining our Digitizing the Curb webinar. We're looking forward to sharing some of the lessons of our recently completed project, pilot project between Urban Movement Labs and IBI's Curb IQ team. A few logistics as we get started, as I see folks kind of trickling in. It seems like we have a, um, a good sized group to get going. I believe everybody is muted as you enter the webinar, but just in case, I kindly ask you all to double check and make sure that's the case to limit any disruptions. Also, please feel free to use the chat box if you're having any technical difficulties. Our team is monitoring that. And you also should see a question and answer you know, kind of tool on the panel. Please feel free to use that during the presentation to drop your questions. We look forward to having a good conversation at the end of the presentation. Lastly, my colleague Jorge is going to be dropping a welcome message with links to our case study. So we invite you to download and review that at your leisure. But he'll also be sharing a question to invite everybody to share your name and organization into the chat so we can get a sense of who's joining us today. And I think that's enough logistics for now. But as mentioned, if something were to come up, please don't hesitate to flag it in the chat and our team will respond. So to get things going, my name is Rogelio Pardo. I am the program director here at Urban Movement Labs, or UML for short. For those of you that may not know who or what Urban Movement Labs is, it is a nonprofit organization that was originally founded in 2019 within the mayor's office and incubated in 2020 by our dynamic board. The goal of Urban Movement Labs, which spun out into its own nonprofit a year ago with a full staff that includes myself and 4 other individuals, is to develop a space where we can facilitate collaboration between communities, public agencies, and mobility technology companies, so that there can be a collaborative approach to testing and understanding how new mobility technologies operate in new or in urban environments. We do most of this collaboration through pilot projects in smaller geographies to learn about how these new tools can enhance mobility, existing mobility challenges, mitigate any new challenges that emerge, and find ways of bringing mobility technology tools in a way that benefits all community members. We're excited to share a little bit about our existing partnership with IBI and their Curb IQ team, which is one of our first partners as a staff. And it's also the first pilot project to be completed. A little bit about IBI. While they're most commonly known as a professional and planning services company, their Curb IQ team works to develop software tools to facilitate parking and curb asset management. We partnered with them to learn about the capabilities of their augmented mobility mapping tool that helps develop digital inventory for curb regulations within different urban contexts. And with that introduction, I'd like to pass the presentation over to Peter Richards, the product director, and Jacob Malo, the curbside mobility specialist with IBI, to walk us through the pilot project, our approach, and our findings.
Great. Thank you very much for that introduction. I'm Peter Richards. I'm a product director of Curb IQ, and we'll take you through a few slides on Curb IQ, and then Jacob will talk about the pilot project in great length. So before we dive into the specific details, I thought I'd set the stage over the next few slides of what Curb IQ is and how it was used for this project. So Curb IQ is a software solution. It can help create, manage, and share curbside regulations and inventory in a visual way. And there's a couple screenshots there just showing what the viewing module and analytics module look like. On the next slide, we'll just quickly go over the full suite of tools that Curb IQ offers for cities, consultants, and third parties that are curb space users. We worked with cities to understand their data gaps and planning needs, so then we built this functionality into Curb IQ. I won't get into great details, but in short, we have Curb Converter. It's a process that we have, or several processes that we have, to create a digital curb inventory, which Jacob will discuss this process, how we applied it to Urban Movement Labs later on. Once you have this digital curb inventory, we have a solution to view these regulations or inventory, and that's called Curb Converter. We then have Curb Manager, which is a way to quickly and visually click and edit these regulations and keep them up to date. And this is a big gap that virtually every city we've worked with has. We then created an analytics module called Curb Analyzer, and this helps you understand things such as curbside supply, demand, revenue, and this can be broken down into a given street, zone, or across the whole city. And lastly, we have a series of APIs that we can share. This is so third parties can learn the curb rules and integrate that into their decision making and routing. We can also ingest APIs. So this allows us to show real-time parking or real-time transit information, bike share information, essentially a complete mobility package. On the next slide, we highlight a few deployments that we've completed. I think we've shown 6 here. For example, IBI Group is leading the Southern California Association of Governments curb space management study. It's the largest study ever completed in North America. And as part of that, we have collected curb inventory data in Santa Monica, Santa Ana, Anaheim, and Riverside for parts of that to help deploy pilot projects. We've mapped entire cities, such as shown at the top, over 1,000 curb miles, curb kilometers, and also helped out with the award-winning Cafe TO program with IBI Group and the on-street patio program in Toronto, and also parts of other cities, downtowns, subway projects, all sorts of use cases. So with that behind us, I'll turn it over to Jacob to talk about how the Digitizing the Curb pilot was put into place. Jacob.
Thanks, Pete. So, hi everyone, my name is Jacob Mallow. I'm a product manager for CurbIQ. And as Pete mentioned, we have a bunch of great tools for CurbIQ, but I'm going to focus today on the pilot we did that is kind of the first step in curbside management, which is actually collecting this data to use on these various visualization, management, and analytic tools. So as Pete mentioned, we have multiple curb converter methods that let us collect, digitize, and standardize curb regulation data. All these methods convert our data into industry standards. The 2 most common that we use are Curb Data Specification, or CDS, developed by OMF, as well as CurbLR, developed by Shared Streets. And that's what our platform runs off both of these. Looking at specifically the methods we use, firstly, open data automation is definitely our most streamlined and efficient method, as it doesn't even involve us having to go into the streets to collect data. And essentially what it does, it takes any existing open georeference data that a city may have, and using our patent pending processes, automates the process of taking this information and turning it into a digital curb inventory. So this can be anything from accessible parking data sets, parking meter data sets, complete signage data sets that cities may have. We often find that cities have some of this data and maybe even a very wide array or multiple data sets. However, it may not be complete, it may not be up to date, and hence we can't use it to generate a complete curb inventory. And that's where we have to head out into the streets, where other 2 methods come into play. So the first one is our curb level surveying method, which is a bit more of the standard method of walking the streets and noting down information. However, we have some tools to streamline this. We use typically 2 open source measurement tools, Shared Streets Curb Wheel, as well as Esri's Field Maps collection app, and then couple that with our automated scripts that can take all the information collected in the field, whether that be the attributes or the images or the physical locations, and once again turns that into a standardized digital curb inventory. And then we also have our augmented mobile mapping process. So mobile mapping is really just surveying geospatial data using a camera or sensor mounted on a vehicle. And what we've done for augmented mobile mapping is augmented this process with machine learning, so where data is analyzed and processed using computer vision to help speed up this process. So we are able to process those images and generate a digital curb inventory from all the signage that is captured. So we've used all 3 of these processes in a variety of applications and found that they all worked well. However, we really started to look at the question of how can we use these to scale up to collect curbside data at a citywide, region-wide, and even more so North American-wide scale to create digital curb inventories. And that's where the pilot that we partnered with Urban Movement Labs came into play. So what we did is we wanted to collect some data in Los Angeles and see which of our methods could be used to have scalable curb digitization. So looking at the pilot specifically, as mentioned before, motivation was a lot of cities may have some data on the curbside, but it's often not complete. And many cities are starting to look for this data. They see a lot of value in it to better understand their curbside, to make the curbside more accessible, more equitable. And yeah, they realize that having this data in a digital format can have a big value to them. However, the challenge with this is that we have several conventional curb level surveying methods that I mentioned before, but to use these on a citywide scale can be quite resource intensive and take a lot of time. So they're not necessarily viable for big cities like Los Angeles. And that led to our guiding question of, could we use our augmented mobile mapping solution to make this method or to make this data collection process scalable at a citywide or region-wide scale? So looking specifically at what we did for the pilot, we picked 4 different areas in LA County. These areas we tried to pick to have different geographies, demographics, and densities to really get a wide sample of what we encounter in any given city. So we went with the area of Maywood, which is a residential area, relatively low density. Warner Center, which is actually a transportation technology innovation zone for the city of LA. That's more of a medium density area. Hollywood, which we have a bunch of mixed uses there, relatively high density. And then lastly, South Park in downtown LA, which is considered a central business district, very high density. So for each of these areas, we first used our more conventional curb level surveying method, and in this case, we used Curb Wheel to kind of act as our control for the data that we collected. And then in all those areas, we also completed our augmented mobile mapping process. And what we're going to do is compare the final curb inventories we get to see how effective each of them were in each given area. So here's a snapshot of what our final digital curb inventories look like on the CurbIQ platform. I'll actually show the CurbIQ platform in a minute and dive into some of these a bit more, but you can see there that all the areas kind of varied in size. As you can kind of see from the colors, they varied in the amount of regulations we were dealing with as well, but I'll jump into those more in a minute. So as for the actual results, looking at how augmented mobile mapping performs, we have a breakdown here of looking at lower density areas compared to higher density. We see that for the collection speed, so how long it actually took us to drive around and collect this data, it was relatively quick in lower density areas, whereas for higher density areas, we got slowed down quite a bit, whether that be from increase of traffic, more lights in the area, difficulties with routing due to one-way streets, turning restrictions, etc., and having to go back and hit some missed roads due to all those different restrictions. For sign detection rate, so the ability to actually detect all the signs that we're looking to capture, this worked very well in lower density areas between initial collection as well as inference. We were able to capture virtually all signs. And for higher density areas, this worked relatively well. However, we did find that there were some obstacles such as vehicles, whether that be delivery vehicles or buses, as well as construction and other blockages that made us miss some signs. Sign geolocation precision, so accurately locating where the sign is, this is where we saw our biggest discrepancy. This worked well enough for our purposes in lower density areas. However, in higher density areas, due to the urban canyon effect and the vehicle moving at a relatively fast speed, we found that it was difficult to get an accurate location of each sign that we captured. And then lastly, for sign content comprehension, so the ability to actually read what was on the signs, this worked very well for lower density areas. We were able to capture everything on the signs using our robust automated processes. However, in higher density, there tended to be a wider array of signs, a lot more information on them, and we had to do a bit more manual intervention to capture all this information. So you can read our report that we published with UML to get the full details and read all about the different data we collected, but I like to pull out this graph kind of to provide a high level summary of what we found. And it's that we have a graph here of overall speed of data collection compared to a metric we use called overall sign accuracy. And we found that there was an inverse relationship between density and data collection accuracy for augmented mobile mapping. So sure enough, you see on the graph here, South Park and Hollywood in more dense downtown areas are not only was our speed slower for data collection, but also our overall sign accuracy. Whereas for Warner Center and Maywood, where it's less dense and less of those obstacles I referred to before, we have much higher speed, but also much higher sign accuracy. So augmented mobile mapping worked a lot better there. Also, you can see down on the bottom right, we have our curve wheel as our kind of control. And although it was very accurate, you see that there's a big cost in terms of speed there as a result. So what conclusions did we draw from the report? Well, in a sentence, augmented mobile mapping works very well in low to medium density areas, with curb level surveying more viable for high density areas. So in effect, a blended solution actually works best for a citywide deployment. You could augment mobile map everywhere, you could curb level surveying everywhere, but to get the best and most out of each solution, a blended solution using both methods seems to work well at a citywide scale. Now, next question is, where do we use each method? And well, we found that low and medium density areas actually make up a huge proportion of North American cities. For example, in Los Angeles, we estimate that roughly 90% of curb miles would be viable for augmented mobile mapping, whereas the rest would be surveyed using typical curb level surveying methods. Now, what does this look like? Well, here's a rough map showing that breakdown. We see that the vast majority of areas in green would use augmented mobile mapping in Los Angeles, whereas some of the denser areas or busy roads would then switch over to some of that curb level surveying methods. And because of this spread of the 90% mobile mapping to 10% conventional methods, we see that we can survey up to 8 times faster with augmented mobile mapping for 90% of the area, resulting in the entire city being surveyed nearly 5 times faster than conventional methods alone. So before Pete, I pass it over to Pete to jump into how to make the most of this digital curb information. I'm going to show what some of our data look like on our Curb IQ platform. So switching over to Curb IQ platform here, what you're looking at is Curb Viewer, so our visualization platform. You can actually see our 2 different pilot areas in Hollywood and South Park here. I'm going to zoom in on Hollywood. So obviously on the map here, or on the right here, we have our map. What you're looking at is a empty or general curb inventory. We have the ability to show satellite view, measurement tool, integrate real-time data, as Pete mentioned. But what I'm going to start to do here is use our left panel to show some of the regulations that we collected. So starting with some of the typical parking restrictions, you'll see as I select options in the left panel here that the map becomes populated. Sure enough, if I zoom in on one of these streets, we now see where there's paid parking, where there's no stopping, where there's no parking, depending on what signage and what regulation information we collected. If I go and select a specific segment, so on North Cherokee Avenue here, we now have more detailed information from what we collected on the street. So we can see the number of spaces here, the parking time limit for at this given time at 9:50 on a Thursday. I could change this time and this would update accordingly. We could see the price. So in this case, it was $3 per hour, and then the source. So all this data that we're showing here is from Curb Wheel. And then also we have our 24/7 breakdown of what you can and can't do at the curbside. So all this was the different regulations that we collected and layered and standardized in our data set, but you can see here throughout the day, Monday to Friday, we have paid parking, slightly different times on the weekends, and then otherwise we have free parking. So these were kind of the typical parking regulations. If I go ahead and select special designations, which we have a myriad of throughout LA, you see that the map has a lot more color on it now. And sure enough, if I say go select a different segment with some of these colors, we'll see that here we have a commercial loading zone throughout the day, one space, parking time limit 30 minutes. Once again, this information came from Curbwheel, and we have some additional info here, such as no parking overnight and paid parking in the evening. So those are the specific regulations we collected, but there's also some more of the raw data that we can show on the CurbViewer platform. So if I scroll down here, you can actually see all the signage we collected with augmented mobile mapping. So I don't want to select all of these at once because it can get a bit overwhelming, but say if I select the no parking signage, we can see all the different signs that we collected here. Similarly, parking restrictions, accessible parking, etc. And if I were actually to go and select some of these signages, good spot down here, turn on accessible parking, select this, we can customize what's actually shown here depending on what's collected. But if I were actually to select the street image, we could see the image that was taken from the vehicle. We see the specific sign detected. And if I were actually to select the sign image here, you can see the specific sign as well. And sure enough, for that segment here, we have the accessible permit shown 24/7, which is what the sign indicated. Similarly, if I were to say, turn all the no parking restrictions, select here, I can select the given sign image, and we see that no parking from 6 a.m. to 3 p.m. And sure enough, if I select the segment here, we see that no parking on Sunday from 6 a.m. to 3 p.m. So that's all the signage that was collected through mobile mapping, but we can also show additional assets that are collected through conventional methods, such as Curbwheel or using the Field Maps app. So for this pilot, we collected traffic pole information, signal controller cabinets, but really anything can be collected, from park benches to trees to parklets to curbside patios. As long as it's configured, when we go out to collect the data, we can show it on CurbViewer afterwards. So here's some examples of what we collected. We also have fire hydrants, parking meters, bike racks, and sure enough, if I zoom in on some of these, if I select a given parking meter, I can have customized information pop up here, as well as some information on the bike racks. So in this case, we just show capacity. But any of this information, if we want to collect specific, like the state of it, whether it's broken or not, damage done, height, you name it, as long as it's configured when we're out in the field, we can then show that information on here. So that's kind of a little bit showing of what we can display on CurbViewer from all the data we collected and what kind of information we can collect with our curb converter methods. But now I'll give it back to Pete to kind of talk about how we make the most of this digital curb data.
Great, thanks, Jacob. So Jacob went over a variety of ways to collect this data, more specifically the comparison between the two methods. But what do you actually do with all of this data? So I'm not going to go through this slide you've already seen in great detail, but essentially it highlights what you can do with the data. You can collect it, digitize it, then view it, keep it up to date, or implement new regulations, understand the supply, demand, revenue with analysis tool, or share it and integrate it with third parties to really get the value there. Slide, please. I won't go in great detail here, but this is a static version of the demo that Jacob essentially just did. The one thing we didn't show is that there's a public-facing simplified view in terms of turning over to the public to help decide where to park, if that's an option as well. Next slide, please. One of the solutions we didn't show was Curb Manager. This essentially allows you to keep that map, that data up to date You can click on segments, add regulations, select, parse regulations in half, update them, review them. And then you can also create scenarios to, if you want to put in a bike lane or patios and understand and have that data visually or spatially to show what some of these options look like. And you can sort of see in the top screenshot, there's a log. You can pre-select, you can basically select regulations for any closure date. So you can, if there's construction or events like sporting events, you can annual parades, you can set it and forget it. So when March 17th comes around and there's a St. Patrick's Day parade, you can have that closure pop up, and then anyone pulling that API or viewing Curb Viewer or the public-facing version, they would have that information set in advance. And the great thing is, since you're doing this all digitally, you have a log. So if you go back or go back when the usage started, you would have those regulations in place. And then you can start to do things such as see the progression towards non-auto curbside designations, perhaps, or other targets that you may have in place. Next slide, please. So this is some screenshots of the Curb Analyzer tool. It essentially allows you to understand the curbside supply, demand, and revenue. So on the supply side, shown in the top screenshot, you can select a city block, neighborhood, zone, a larger area, and you can get a breakdown of the curb inventory at any time. And then if there's demand, there's lots of real-time sensors and meters in Los Angeles open data, and you can just pull that, or other cities through other APIs like garages or machine vision cameras, sensors, other sources. You can start to pull that data in and have historical or real-time data to see how the curbside is actually being used. Then you can start to understand the trade-offs, how it's designated or what the inventory is and what the demand actually is. And then if there's revenue data, we can calculate the actual or potential revenue from paid parking or potentially paid loading zones, which is an emerging trend in curbside management. And importantly, the scenarios that we set up, we can compare and contrast different usages or different inventory. So some use cases might be the desire to install a bike lane or a rapid transit lane, just to understand the curb inventory trade-off and revenue trade-off. And you can see, for example, how many paid or free parking spaces are in a given area. You could also overlay parking citation data or census data like income, and then you can make equity-based decisions, where to place rapid transit or bike share or EV charging facilities. What's the trade-off of one parking space for one loading if there's already 200 within a quarter-mile, half-kilometer radius, things like that. So to evaluate competing interest, have data-driven solutions rather than anecdotal stories about parking. Next slide, please. And then we have an API, which, like most APIs, they're effective data communication between users such as cities and private companies, and that's necessary when you're providing scalable mobility solutions. So we're not exactly reinventing the wheel. We're using established formats and guidelines such as the new Curb Data Specification, CDS, and CurbLR, which a handful of cities still use through shared streets, and that's how we disseminate data to people who want to use it. So it basically provides relevant curb information through standard inputs in a RESTful API. So this can be integrated by all the icons shown at the top. And that way the latest information is up to date. So if there's a closure or anything, anyone pulling that information, or even a permanent change, parking payment apps or enforcement companies, they'll when they call the API, they have that latest information based on where they are. And another use is if there's a no stopping zone, for example, and there's a TNC drop off, transportation network company like Uber and Lyft, the API can direct you to the nearest allowable drop-off spot or pickup spot to avoid circling the block and cruising for parking, and just set expectations of the passenger. You can organize that meeting spot based on what restrictions are nearby. Next slide, please. So given that there's a handful of cities, mobility providers, and curb space vendors on this webinar, happy to work together if there's opportunities or ideas that may have popped in your head while watching this. We didn't cover every element of CurbIQ given the time limit, so happy to set up a meeting. But in summary, we have curbside tools, so happy to work together to enable staff, cities, mobility providers to visualize, manage, and analyze this data. Data collection is a big one. I guess the middle part or core of this webinar. Cities ask us about this all the time. A lot of consultants actually reach out to us to use us for parking projects or curbside projects. So we're able to help use these tools depending on what's in place or what's needed to map existing curb regulations or convert existing data. And then pilot projects, we have a handful of these on the go with various partners. Happy to review high demand or conflict or innovation areas to pilot initiatives, look at real-time availability, other initiatives for your projects or cities and advance mobility together. I believe that is the last slide. So I think, Regilio, back over to you.
Awesome. Thank you so much, Peter and Jacob, for that walkthrough. I know there are several questions, but before we get to answering, we have a couple of questions that we want to generate some word clouds from if folks are amenable to that. So if you don't mind grabbing your phone or going onto slido.com and inputting that code 851717, we have a pair of questions to ask what other type of data might be helpful to collect using this or similar tools and how that data might be used. So I'll leave this up for a minute or two. And while folks chime in on Slido, we can go ahead and ask, or rather answer, the first question that came in through the Q&A. So Peter and Jacob, obviously we talked a lot about the data collection aspect, but there was a question about real-time data and the ability to integrate all these different data sources that are now in urban spaces to update the database. How does CurbIQ incorporate real-time data, be it in accordance or in response to changes in policy or to closures for emergencies, filming requests, or special events?
Yeah, that's a great question. I think some of it was covered off after in the Curb Manager discussion, but we can integrate APIs. So if there's an API for construction and there's smart work zone APIs and things such as that, that can all be integrated and displayed, and we can change the curb regulations accordingly. And then that can be pushed back out through our API to anyone ingesting it. And in terms of construction, filming, special events, again, we can use Curb Manager to make those changes and implement them. It can be daily, for a week, all that information. And then when Jacob did the demonstration to show that right panel, we can actually provide links to the information, email address, if there's an environmental assessment or other construction websites, we can link to all that for additional information.
And I think just to add, a big part of that, which is going to help streamline how that data is shared, is with Curb Data Specification or CDS, where they're developing universal APIs that can share that real-time data. So whether it be a sensor, whether it be a camera, whether it be a parking app, all that information can be in one format that can then easily be ingested or shared by others. And then actually, funny enough, this week at the working group session, there was a discussion on the work zone data exchange, which is a separate standard that's for construction and road closure data and how that integrates with CDS. So I think as we continue to move forward and this becomes more common, we're going to find easier ways to integrate all that data.
Thanks, folks. And I want to just pay attention to the Slido that's been populating in the background for the last 2 minutes or so. It really looks like there is a strong desire to see data associated with competing users of the curb. So seeing a lot of shared and micromobility options, scooters, transit access, parking of zip cars or other shared uses, and a lot of pedestrian activity. So I think, one, can we transition to the next Slido question to kind of keep this community engagement or just kind of a general input going? But I think this segues nicely into the next question that we received, which um, for Peter and Jacob, curious how clients or partners that you've worked with in the past have asked you to manage competing interests of the curb. How have you done that so far, and how might you plug into or collaborate with traditional planning projects in that space?
Yeah, that's a great question. That's something that was done manually in my curbside consulting practice at IBI pre-Curb IQ. A lot of that is what we showed with Curb Analyzer, and just once you have that information on the curbside inventory, you can start to select and understand what the inventory is. And once you have the demand, you can contrast the two to one another. We've helped with bike lanes and also pop-up patios or on-street dining. And the trade-off is often parking and the associated revenue dollars versus a patio and restaurants. Some cities have curbside management strategies, and they have like a hierarchy of curbside needs. To very few cities, or could align with their complete streets guidelines. But what I showed in Curb IQ and Curb Analyzer specifically was that graph and the trade-off. We have a comparison dashboard that can show like a before and after, or scenario 1 versus 2 versus 3, and understand, do we have 200 parking spots within a quarter mile and only one loading zone, therefore taking away, 0.5% of a parking spot to add, a loading zone, just to try to understand those trade-offs. And then you would augment that with demand data that you're collecting to say, hey, we have 10 curbside spaces, they're all parking, but pickup and drop off is happening 50 times an hour. So why don't we just give them some space, eliminate the double parking or the safety concerns, and actually just give them the space, and then more importantly, monetize that space. Why don't we start charging for pickup and drop off via cameras, geofencing, other initiatives, charge for loading, and really start to monetize that curb, which kind of keeps that revenue in check that many cities are interested or afraid of losing by repurposing parking.
I think one other thing to add just quickly is, having worked on it with a couple of cities, is the amount of time they realize they're saving. Because if they have this digital curb inventory, when they're looking to make a road closure somewhere or put in a patio somewhere else, they don't have to go out and survey to try and understand what's there. They just have that information at their fingertips, so they can make those decisions more quickly, and also share that information with others to be like, hey, we're taking away this paid parking here, but right around the corner there's 30 more spaces. So help streamline those processes to implement those changes.
Thanks, Peter and Jacob. And Peter, you kind of started to touch on it about monetizing the curb. And somebody's asking, what might the most compelling argument financially for a city agency or decision maker to adopt a comprehensive curbside strategy be? And wondering if you've had that kind of conversation with other urban environments or city agencies.
Yeah, certainly. A lot of conferences and even RFPs are switching from the parking focus and looking at the curbside. Parking is a subset of the curbside, and the curbside is not just parking. And if COVID showed us one thing, it's definitely that there's a lot of uses and how to monetize that. So I think, understanding your curbside is a great first step in terms of the inventory. A lot of these changes were happening ad hoc, haphazardly, drawing on PDFs with highlighters and not understanding what the trade-offs are. But if cities had this digital data and revenue data and all of it compiled, the changes could have been made based on origin destination surveys, demand surveys, revenue, trade-offs, any kind of plan. So I think the emergence of first CurbLR, then the curb data specification and other standards, and then just the general industry understanding of the importance of this and certain tools and stuff is definitely nudging things in the right way. When we first started doing curbside management strategies 7-8 years ago, Toronto, where I'm located, did one of the first in North America. And I think in the last, not counting 2021, I think there was about 5 or 6 RFPs that went out. Last year was more than double that in 1 year alone. So I think cities are preparing funding for this, recognizing the standards, setting up things, participating in these working groups, and the knowledge base and interest has greatly increased. So I think as long as that trajectory continues, I think mobility will be in a much better place.
Thanks, Peter. Something that you highlighted, so when it comes to monetizing the curb, typically we want to look at the most dynamic spaces, and often those are more urban or dense downtown. You highlighted the challenges of using geolocation tools in a dense environment. Um, there was a question about whether the CurbIQ team has considered using autonomous robots or people using scooters or bicycles that might be a little bit faster than the curb wheel tool to collect that data to kind of overcome visual blockages on the curb as well as geospatial location challenges. Is that something your team has considered or might be able to look at in the future?
Yeah, I can take this question. Yeah, we've definitely explored different options. It's always trying to find that balance of um, additional data or additional accuracy you're getting and whether the payoff's there or not. Um, there was a point where for augmented mobile mapping, we discussed mounting cameras on like a bicycle and biking around so you could maneuver a bit better and get those missing signs. So that's something we've looked into. We do feel though, if you're out of the vehicle and going at slower speeds, at that point, if you're just looking at those downtown dense areas, maybe it just makes more sense to use a curb wheel or use other open source tools to pinpoint those exact locations and capture those images explicitly. So yeah, there's that bit of a balance there. I think there could be room for a middle ground to speed things up a bit and find something between augmented mobile mapping and kind of the more conventional methods. But we've right now proceeded with kind of those two to kind of find that balance and have an option for denser downtowns versus less dense kind of outside of the urban core.
Great, thanks, Jacob. So we talked a little bit about other assets that could be collected and how that might be beneficial. A question came through about whether or not your tool could be used to kind of assess the condition of different assets, whether it might be damage to signs or painted curbs or highlighting where signs might be knocked down. And maybe just to add on to that question, curious about how CurbIQ adjusts to different signage standards in different jurisdictions.
Yeah, so in terms of first part, assessing conditions, there's two ways this can be done. The first one is by when you're actually surveying, we could have an additional attribute for like each sign you capture. So if you're walking the street to then note good, bad, broken, you can actually note that condition as you're surveying and walking. So that's actually doing it while they're on the streets. The other option would be to do that afterwards when we use our processing to identify signs and identify content on signs. We could also train our models to try and understand the conditions of the sign. So seeing how faded the text is, maybe if the sign is bent or broken, we could train our models to look for those specific aspects if that's something a city's interested in. And oftentimes with a given city, it's upwards to hundreds of thousands of signs. So oftentimes we just need to have a small sample of that, train on that, and then can apply that to the rest of the city. As far as dealing with unique signage, similar idea here where what was great, part of this work in LA helped us have a model that works on any signage now virtually in all in California because signs are very similar across different cities. But obviously, depending on different places you go, they might have different types of signage. I know in Canada, it's relatively consistent. A lot of states use, I believe it's called MUTCD standard for signages, which we're trained on. But say there is a city that has unique signs. Once again, often cities are quite big. We'd have to do a small area of that and manually train our models. But then from there, we can apply that to the rest of the signs. So it's just a matter of training and then applying our models.
Yeah, the two big ones are Montreal. We've converted French signs, and then parts of Mexico as well for Spanish. So actually, CurbIQ is in Spanish and is just being translated into French as well.
Awesome. Thanks, Jacob, for providing that overview. Looks like the topic of maintenance, which it's not always the most popular or most exciting political topic to discuss, but it did generate some follow-up questions. I've got a follow-up question asking if the CurbIQ tool could be used to collect data on potholes or unsafe driving conditions that either state or local DOT might be interested in understanding.
So our models that we use for CurbIQ aren't specifically trained on that. Actually, where some of our models originally came from was from a other practice that we have at IBI Group that does train specifically on those types of things. We tend to find the cameras you're using need to be slightly higher quality to try and detect things like cracks and potholes. We have used those cameras in other applications with this other practice. We've been doing it now, I think, for like 20 or 30 years, a lot of it out in the UK, but also in North America. So there is that ability. We find though, we have this specific augmented mobile mapping just because if cities are just looking for curbside data, using those more expensive cameras can be quite cost prohibitive. So we've kind of separated into a separate surveying method. But yeah, if a city was interested in that, it often makes sense to group those projects together. So collect curbside data while you're collecting pothole data, while you're collecting, repair data to signs. That can all be done in one swoop.
Great, thank you. And maybe what looks like maybe the last question. There's a question about CurbIQ's data and integration with ride sharing or micromobility data. Also, how might the CurbIQ tool be integrated into, Google Maps or Uber's platform? Is that something that the CurbIQ team is looking into or has explored conversations around?
So I can start and then you can finish, Jacob. So for rideshare or I guess car share, like if you mean like a Zipcar or something, there are designations in some cities where there's actually on-street curbside designated for those. So those would be mapped. If there is off-street or an API, we can even show the real-time availability. I know you wouldn't necessarily go to CurbIQ for that. You'd go to the app itself, but rather than going into multiple apps, that could be displayed there. Or if there was maybe a agreement where there was like a shared parking agreement, if the car is in use and another use could go there, it's another way to better use the limited curbside. That API could be ingested. In terms of sharing the information, yeah, there's an API that could be integrated with commercial vehicle drivers, transportation network companies, and such. And yeah, it's up to I suppose Google Maps and other navigation platforms to want to ingest this at scale. Happy to obviously share the data, as ultimately that's where people would go for trip planning, not to CurbIQ, but to Apple, Waze, or Google Maps, and we can definitely share that information or integrate it. Jacob?
Yeah, and I think that kind of relates to sort of our bigger vision where we see curb data heading, in the sense that we often compare it to transit data 10, 15 years ago, where you had to go to each city's individual website to go look up a bus schedule in a PDF, and it was a pretty archaic process. And then I think it was actually Google that made it happen, where they worked with the city of Portland to then have a standard to provide that data, that transit data, both real-time and scheduled data that can then be ingested onto Google Maps. And now virtually every city in North America has GTFS feeds to pass on that transit data to something like a navigation platform like Google Maps. We see down the road every city having their own digital curb inventory that they constantly keep up to date, and then they use APIs to provide that data to navigation platforms like Google Maps, so that when you're on Google Maps and routing, you're automatically getting routed to a loading zone or automatically getting routed to a paid parking spot opposed to your actual address, to help streamline that route planning. So that's kind of the vision we see with how curb data can be used ultimately by end users, but also why cities will want to keep it up to date.
And there's infrastructure light or infrastructure without the need for it, in terms of if there's parking payment and smart parking meters, we can integrate the real-time payment data. So you wouldn't necessarily need sensors or cameras to have that real-time occupancy. You'd have real-time payment occupancy, which could then be displayed in CurbIQ and then shared via the API for the routing that Jacob noted.
One last add-on question to that. I think the conversation of MDS and CDS data standards has been missing from this conversation. Curious if you have any comments about how CurbIQ plays with MDS and CDS.
Yeah, and I think that kind of relates to what I was saying with the general transit feed specifications. Like we see CDS being that standard of how cities and municipalities pass on curb regulation data to mobility companies, navigation platforms, PMC companies, etc. And that's why our API that Pete talked about before is powered off of CDS. So we use those standards so that moving forward, there's a more universal way to ingest and accept curb regulation data to make it more commonly used. And then on the MDS perspective, obviously MDS and CDS are both run by OMF. There is integration there of how we could pull in MDS data to show where there's rides being had or starting and finishing, but also to show scooters where there's dedicated curb zones for where they can start and end trips.
Thanks, Jacob. And I think I'll be able to take on the last question, which asked if the presentation or the information presented in this webinar would be available. The answer is yes. My colleague or our colleague, Lindsay, has posted a link to the case study that includes all this data and more, as well as contains contact information for the CurbIQ team, as well as for the Urban Movement Labs team. So before I wrap us up, Peter and Jacob, any last comments or questions you'd like to put out?
I think the questions were great. We didn't get to answer all of them. I think we'll answer offline via email if that's okay with the askers. But yeah, no, I think the changes that have happened, we came out with CurbIQ before the pandemic, and I think all the changes in recognition and even the questions today and having dozens upon dozens of people register today just shows the interest in the curbside. So it's an exciting space to be a part of, and thanks to practitioners and curious people that asked all the great questions today.
Awesome. Well, with no other questions, or with time running out rather, I want to thank everybody again for attending, sharing your time and your questions and curiosities with us. As noted in the chat, if anybody has any questions or wants to follow up, please feel free to contact us via our websites or via our emails. We look forward to being in communication and look forward to the next webinar. Have a great one.